Hello, good afternoon.
Hello.
Servus.
Hello.
Servus.
Servus.
Hello, good afternoon. Welcome to the
Good
webinar.
afternoon. Welcome.
Welcome.
While we are waiting for everyone to join in the next minutes, we would like to ask you a few questions. The first one, where are you joining from? And what time is it for you? You can put it into the chat so we can see where you are located and if it's good morning to you or good afternoon or good evening. Hi, Kevin. Welcome back. Oh, 10 a.m. in the morning. Good morning to you, Jamie.
Good morning.
Oh.
Can you hear me?
Yes, yes.
Oh.
Good morning. Have a cup of coffee and enjoy the webinar.
Thank
Lisbon. Hi, Kevin. 3 p.m. 1 hour ahead. No, later. Hello, Frank. Good old Germany. Where exactly in Germany are you located, Frank, if you want to share? Hi, Mark. Good afternoon.
Good afternoon.
And the third question we would like to ask you, on a scale from 1 to 5, how ready is your team and you for the AI-assisted development and the respective traceability as a precondition? So 1, you've never heard of traceability and AI, and 5, you're doing it on a daily basis, traceability using AI, or the other way around. The AI uses the traceability as we will see today. Okay. Beginners there. Near Strasbourg, okay. .5, very precise. Thank you, Kevin. So everyone who joined lately, we would like to ask you from where are you joining from and what time is it for you? 2.5, Roberto, okay. Already some progress. That's good. You can put the answer in the chat. Where are you joining from? Which country, which location, which city, and with what time is it for you? And the content question is, on a scale from 1 to 5, how ready is your team's traceability for AI-assisted development? Okay, let's start with the webinar. Hello, everyone, and welcome to today's webinar, which is special. The title is Escape the Traceability Matrix. So you take the red pill or the blue pill, you decide. Before we start, we would like to ask you to follow some rules. As you might have noticed, this is an open mic webinar, so you can unmute yourself, but please stay muted during the presentation until the Q&A session starts. If you decide to unmute yourself, be advised that this session is being recorded. As mentioned, we will have a Q&A session at the end, and we will happy to answer as many questions as possible. You can put your questions already into the chat. I will collect them and read them loud at the Q&A session, or you can raise your hand and we will call you one by one and you can ask your question. Thank you very much. So let's start with an introduction of today's speaker. My guest today is Dr. Thorsten Schlathölter. He is a physicist, software engineer, and founder of Ariadne Systems. Not to be confused with Ariadne. So it's not rocket science today. Thorsten studied physics at the University of Osnabrück and earned his PhD in theoretical physics. His professional path runs through three distinct domains. He worked in medical technology. He worked for Philips Medical Systems in Hamburg. Oh, we have an echo here. Thank you. He worked at Philips Medical Systems in Hamburg, where he developed a virtual bronchoscope in the digital imaging lab. He worked in financial services, implemented a customer relationship management platform at WestLB, and later worked as a project manager at Hewlett-Packard, serving banking customers. And he has worked in engineering. He built a platform that connected functional safety and security analysis methods such as FMEDA and FMEDA with system design and requirements. I find that specifically interesting. After several years as a freelance test automation engineer, Thorsten has founded Ariadne Systems and built Ariadne, the traceability infrastructure he will present today. Thorsten, welcome.
Yeah, thank you, Ron. Thank you for hosting this session, and thank you for all of you being here and joining us today. Glad to be here. So let me set the stage with a scenario some of you might know and recognize. You wrote the requirements 6 months ago. You wrote the code last week. Today, the auditor asks, where's the link between them? You point at a comment in the code that says, implements requirement 1, 2, 3. The auditor asks, is that comment up to date? You don't know. That gap is what this webinar is about.
And we are the assessors or auditors, Ernest and I. We asked these questions, and our observation is that the dashboards, the traceability dashboards, are often only maintained for the assessment or audit, in best case for a specific delivery. But after this, they deteriorate and they are never maintained. And this is the gap we are talking about today.
Yeah, but before we go into the topic, let me also say a few words about Ron. Some of you will know him already, but for those who do not, this is Ronald Melster. Known in the automotive world simply as Ron. So I also know him as Ron, yeah. As a principal ASPICE assessor, he works with organizations, projects, and people on reaching their process goals with a clear focus on balancing structure and standardization with pragmatism and efficiency. But Ronald is more than an assessor. He's a mentor, coach, a sparring partner, someone who helps teams not only understand ASPICE, but actually live it. He's worked with Bosch and Carmack, Nippon Seiki, Audi, Porsche, and Jira, influencing hundreds of professionals along the way. One of the achievements he's most known for is leading a Bosch development division for around 7,000 engineers worldwide to capability level 3. Ron has been active in the automotive industry since early 2000, and in 2005 he became one of Europe's longest serving ASPICE assessors. For him, assessments are not about ratings, they are about empowering teams and explaining the why behind every process. And there's a personal reason I'm standing here today. About half a year ago, I had the early vision of the idea that traceability could become a structural property of the code, not a deliverable produced before audits. I shared it with Ron. And Ron, you listened, and then you said one thing that stuck with me ever since: this could be a game changer.
Yes, and I'm still convinced that this approach we will see today is a game changer, because I've never seen something like this in an assessment or coaching situation so far. What I specifically like about the solution, as we will see later, is that it starts where the developer feels most comfortable. In the IDE, building code, they don't like to switch between tools, Polarion, Jira. They like to be in the IDE and build code.
Yeah, that's it. But ideas are easy to claim. What matters is whether you can build them. So I build it, and what you will see today is what came out of that. Structural traceability, not as a concept I want to define for you, but as something you will see working in the IDE, in the build, in the dashboard, and in a assisted workflow at the end. That's because that's why we asked the question in the beginning. But just jump into the presentation. First of all, let's give you some insight on structural traceability. What is it? In structural traceability approach, requirements from ALM are turned into code, not into comments, not into metadata, into actual code constructs that the compiler treats like any other part of the language. A trace in the code base is a reference to one of these constructs. The compiler checks it the same way it checks every other identifier in your file. Wrong reference, an error gets visible in the IDE, and the build fails at the next compile. So you're always up to date. Because the trace is a language symbol, the IDE treats it like one. It can list every place a requirement is used in the code. Implementation and test side by side, no custom plugin. It's what the IDE already does for code. Now, a lot of current research, if you look into it, focuses on recovering broken or missing links using AI because it's such a fancy tool today that works. No, I mean that work except that traces will decay and builds tooling to recover from that break. Structural traceability takes the opposite position. If the trace is part of the code, decay does not arise in the first place. So recovery is what you need when traceability has decayed, but structural traceability is what you choose so it does not.
And that's a key difference to what I've seen until now in my daily work. Many teams struggle with establishing traceability in the first place and maintaining it over time. And the difference with this tool is that traceability is not built in after the source code is there and the requirements, but it's actually constructed. And I like to distinguish between analytical and constructive quality assurance. And instead of checking after the fact whether the traces are still correct, you build them into the structure so they cannot break silently. And this approach significantly improves the quality of the system and the software, where discipline cannot do so.
Yeah, and where this matters significantly is in regulated development. 3 standards, ISO 26262, ASPICE, IEC 62304, all require bidirectional traceability between requirements, code, and verification. What is interesting is where the volume of these traces lives. Not at the requirements level, that part is relatively manageable. The volume scales in the implementation and verification layers, where every requirement fans out to multiple code locations and multiple tests. And this is exactly where today AI agents write more and more code. But the audit evidence we create has to hold regardless of who wrote the code.
And again, my assessor perspective, as you know, that ASPICE requires traceability along the V model, starting with SW1 to SW6, between all the work products. As an assessor, I do not care whether the code or the work products are generated by AI or by humans. What matters to me is that the traces are there. In the past, they were needed for people to do a proper impact analysis. We will see in the future that AI will use the traces as a context to build a future proof product.
Yeah. But before we go into the demo of the product, a quick look at how the system is actually built. So this is the Ariadne ecosystem. It consists of only two components: Ariadne thread, the backend with all the logic and storage; Ariadne lens, the UI, a rich dashboard for analysis and audit. The two components live inside a Docker container. Can you go ahead with the slides a little bit? They are a little bit animated. So, but okay, this is the component architecture. So we have the two components living in Docker, and they connect to your existing infrastructure. A requirement system on the left side might be Codebeamer, for example, and a DevOps system on the right side, for example, GitLab. The architecture allows different connectors to be plugged in for both sides. Now, Ariadne runs two cycles. This, what you see here, is the first cycle. It's called rec2code. It queries requirements from the ALM, creates typed artifacts, and pushes them via merge request into Git. So the team working on the project reviews and approves the merge requests like any other change. So this is a standard development workflow, very close to what developers experience today. The second one, the second one is code to rec. It's the opposite direction. It reads traced code locations from the code in Git, stores them internally to provide them to the lens component, and optionally writes them back to the ALM, so the requirement knows where it is implemented. Other tools in the field actually run exactly this cycle here. Now, the last component, it's Ariadne Lens. It visualizes all of this in a dashboard, coverage, impact traces, in a tool that lives next to development, not in a separate compliance system. Now, let me switch to the demo. Now, so I share my screen. I share my IDE, and I try to put everything in here into the IDE so that we have better understanding of the whole content. Now, first of all, let me show you the project. It's an AI-generated project, in fact, that is set up against a Codebeamer instance and a GitLab repository. Here, in this view, you see all the requirements making up the system. It's an automotive safety system, which is simulated here by AI. It has a brake control. It has airbag deployment and some shared safety functions. Each carries an ASIL classification. Now, this is part of the code base. It already implements part of these requirements. In this project, the references to requirements live in code comments as free text. Editorial references, that's the way most code bases handle this today. Like you see here, these are the editorial references. To save time, I have prepared a second branch with two commits already created by the system, by Ariadne. So I will just switch to that branch and show you what it created for us. Okay. Now,
okay. If you wonder what editorial references are, I have done a complete webinar just about 7 techniques about traceability. And I will put a link to the YouTube video. I'm on YouTube now, into the chat. So if you want to know what are editorial references, you can watch the video. And in short, editorial references are IDs, as Thorsten just showed, across tool borders. So we have some IDs living in a requirements management tool and other IDs living in the source code. And the weakness is they diverge very quickly. If the code is changed by the developers, nobody will notice that the requirement is out of date or the other way around. So if you're interested into the traceability techniques, you can watch the video.
okay, let me come back to this, to the demo. This below here is a Git commit view. It tells the developer what code changes have been performed when and by whom. And what we see here is what I just did. I pulled in some changes, 2 changes performed by the system prior to this demo, because it takes a while and we didn't want to waste that time. But still, these commits are there. And the first commit here, it comes from the rec to code cycle, which creates the actual artifacts from the requirements read from CodeBeamer. So it's 4 artifacts we see here, 4 files, which have been created in this cycle. And the second one, it's this, is a commit that replaces the editorial references to these here with structural traces pointing to exactly those artifacts generated prior. This is a migration feature provided by the tool, which automatically can transfer these editorial references into traces. So here's what the code looks like afterwards. We still have the original references in the comment, but you see 2 new files next to the comment. Each one points to a traceable in the artifacts which have been created. Each traceable carries the requirement ID. So this is similar here, you see, plus the title of the requirement. It's easy because it's generated. We can just add it to these traceables. So when a developer looks into this, he already sees what this is about. Not just a number, but he sees, okay, this is about brake pressure limit enforcement, for example. So that is actually the whole shift. Note that at this point, a simple promise was replaced by a real contract. And that is what structural traceability is all about.
So we see at the moment 2 things on the screen. Promises in the comment, and they rely on the discipline of the team, of the developers, that they keep the source code in sync with the requirements. And we all know what this means. And we see actual contracts. And these contracts are enforced by the tool, so the source code will stay consistent with the requirements over time.
Yeah, exactly. And they're exactly enforced by the compiler, actually. So the compiler, because this is a code symbol here, it's enforced by the compiler, not by some mystic tool, but by the compiler you work with every day. Yeah, and we have here this traceable, and we can jump into it by using just IDE functionality. So I just jump into it, something a developer does every day. We land in one of these artifacts I've been talking about, and this is how it looks like. It's one of the artifacts. It's a brake traceable artifact. It collects all requirements from the brake system, from the brake component, into one artifact here. And you see right next to the one I just opened all the others. And what we can do now, for example, since this is a symbol in my code, I can use the IDE, for example, to check where is this used. And there's a tool inside the IDE which shows me, okay, where is this used? And there are two kinds of reference in the code base. Traces that mark the implementation. We have seen them already. I can just open it from here. This is what we have seen before. So you see here traces to brake. That's the one reference. And then we have the verifies. So it's here. It's to distinguish the implementation from the verification, from the tests. And it shows where the tests are actually implemented. So at one click, you have the test, which is responsible to test the implementation of the requirement. Of course, this could be plenty of references here for one requirement. They would all be accessible at on one click. Now, that's the code side, but there's the UI side. Now, let's have a look at the UI. This is the UI, Ariadne Lens. It manages different projects. So let's check. Let's just open this project. We've seen the code. You see, first of all, an overview of the total requirements managed by the system. It's 29 requirements. You see the covered status for all the requirements. It's 41%. It's not much. You see different states: verified, covered, uncovered, and deprecated. You see the deprecated are special states of requirements which you can assign to a requirement to indicate that it's not used anymore. So if we had any assignments coverage of deprecated requirements, that would be a technical debt actually. Either the trace has to be removed or the code has to be removed. So it's visible here, right in the UI. The requirements, which are numbered here, are visible here in a table below. All the requirements. There's a broad range of filtering mechanisms here, where we can filter the requirements after special criteria. Now, there's an analyze view, which lets you filter the requirements by certain attributes. These are the attributes I mentioned when I showed the requirements. I said there's an ASIL attribute at each of these requirements, and also a component, brake, airbag. So let's filter all ASIL D of the brake component. We see, okay, it's 6 requirements inside our system, 6 requirements, 83% are covered. 3 of them are also verified at the 60% rate. 2 are only covered, so there's a test missing, and 1 is totally uncovered. This already maps to the, or filters here, the table below.
And as you might know, I'm not just an ASPICE assessor, but also a safety manager. And as a safety manager, I like this view. I asked so many projects, how many of your safety requirements are implemented, how many of them are verified, because that's the precondition for performing a safety case. So filtering by other level and component gives this answer immediately in real time.
Yes, and if we go back into the table, there's a little bit more information hidden behind every single row here. Let's just open one of the verified rows. As expected, you see a trace to an implementation. In this case here, the brake pedal sensor on line 27. You see Who committed it? This was done by Ariadne thread because it was an automatic process. You see the commit char, and you see also where it is verified. Also, same thing, you have the person or the system who implemented this or committed this, the timestamp, and the commit char. For audit purposes, it's even possible to look at the change history. We get all merge requests related to this single change, or not to the single change, but to all changes relevant to the associated code files, let's say. Now, the title of this webinar gives a promise on traceability metrics, but before I show how to create the traceability metrics from this, I want to show you that this is really a round trip. So I will create a new requirement which should show up inside the system and will also pull in another commit where I have previously already assigned some new traces so that the coverage should be increased. Now, let me do this right now. We just add here a new requirement. We keep it just simple. And let's go back. Here, this is what I have created in advance. Some RZD traces for the brake component. Let's pick this change here into our code base. Now, the system needs a little time to pick this up. The cycles run in this configuration every minute. So let me push this. And then we come back later and check whether the system has picked that up. So it's gone. Now, so as I said, both should show up in the dashboard in a minute. Let's go to the tool back and let's talk about the traceability metrics. Well, since all the traces in the system are up to date, I can export from here the traceability metrics. Now, this in the IDE, I cannot open Excel like you know it. I can only open it in this plugin here, but it shows the Excel which was generated by the tool. You see for sheets, an overview sheet, coverage matrix, traces, and orphan traces. The overview gives project name, branch, generation timestamp, and coverage breakdown. The coverage matrix gives one row per requirement with ASIA, component, and trace counts. And then the traces sheet gives you all trace locations with active links into the system where the code is located. In this case, it's GitLab, for example. So you see here, you see back here the location URL and also the commit when this was committed. And there's also a sheet for these orphan traces that reference requirements that are actually no longer in the LM. The content of this file is always up to date, at least with respect to the timestamp when it was generated, just because it's derived directly from structural traces. Now, back to the lens and check whether this worked. We still have here the number of requirements we had earlier and the coverage. So let's see if I update this. Now it increased, it picked up the further requirement and also the coverage increased. In fact, if we filter for RZD, that's what the change said. Oops, sorry. That's what the change said. We should increase the brake component coverage, and that's what happened. Now we have 5 verified, only 1 covered, and the uncovered is gone. So that's the whole thing. That's a round trip. Requirements to type. Oh, sorry.
As a safety assessor, I get a little bit nervous. 100% looks good, but the other numbers, as I said, make me a little bit nervous. I know it's a prototype, you're still in development, and at the end, you hopefully get to near 100% coverage, or at least 100%, maybe 110% coverage.
Yeah, that's Trumpish. This is just a demo project. That's just a demo project here. So I could add some more coverage, but for the sake of showing this, I think this is enough. So this is a round trip. Requirements to typed artifacts, structural traces to coverage to traceable to the traceability matrix on demand if you want, if you need it. For example, if the auditor is on his way, and it's refactoring safe and compiler verified. Now there's a little bit, no, there's much more in here. All the filtering. There's something about this requirement set which is visible here. You can see the trend on the coverage. It's all in the system. I cannot show all this in the demo, but there is a demo system which is available on Ariadne-thread.io. You can just open it and click yourself through it. It's 10,000 requirements just to show that it can handle a lot of data as well. It's the same dashboard, just some arbitrary demo data which is created for you. I'll present the link for it at the end. Okay. Now on, you can switch back to the presentation.
This one, correct? No, this. Okay, go ahead.
Okay, can you go one up? I think we are too far already. Okay, now what we just saw is end-to-end structural traceability, bidirectional links between requirements, code, and test, coverage and impact analysis, refactoring safe traces. This is a complete tool for teams that need structural traceability under ASPICE, ISO 26262 or IEC 62304, or teams that simply want to track the coverage of their requirements in their code base, just for quality assurance. Lightweight to set up. It's delivered by Ariadne Systems with direct access to engineering.
So to summarize, as we all know, traceability is a cornerstone of ASPICE. And I'm really looking forward to your presentation, how you combine this with AI, which is a strong fit. As I mentioned earlier, traceability has been for people in the past and will be for AI in the future to set the context.
Right. And because it's on everybody's mind these days, I decided to show another feature. Structural traceability enables, and that's why we had the question in the beginning. Something which I have intensively using actually during the development of this system, something that makes a supporting AI agent feel like a pair in programming. Let me show you what I mean. This structural, the same structural property that carries audit evidence for the auditor also carries context for AI agents. One mechanism, two use cases. AI agents now write substantial parts of production code. That's a fact. I'm not going to argue that, whether that's good or bad, that's happening, and the volume is growing. The performance of these agents depend on two things: a tight feedback loop and context. context in most setups today means retrieval, pulling in fragments of code that look related to the prompt. That works to some extent, but it's not enough when the task is to extend a complex system with broad history that already implements hundreds of requirements in a specific way. Now, what separates an agent from a senior developer is knowledge. The senior developer knows which class already implements a requirement, which method to extend, where the related logic lives. That knowledge is a byproduct of writing the code. You build it while you build the system. Now, when agents write a growing share of the code, that byproduct does not accumulate the same way. The next agent session starts without it. This phenomenon is sometimes referred to as the missing memory problem of AI. Now, this is where structural traces come into play. Structural traces point back from the code to the intent that produced it, independent of who wrote the code and when the code was written. The agent does not need a senior's memory. It can follow simply the references. So structural traces give an agent in machine-readable form something similar to what a senior developer carries in memory. I can now, back to the project, I will show you how this works. I'm already doing it. Okay. This is a feature ticket from the backlog, a normal Jira ticket with 3 code beamer requirements linked in the description. The job, implement brake fluid temperature monitoring. You have the links down here. These are requirements into the code beamer system. Exactly the requirements I've shown you before. But as I said, we want to provide some memory to the agent before working on the ticket. For this, I have written a Claude Code skill that reads the Jira ticket, follows these links, so it collects the content of these requirements, pulls them in, and pulls additional related requirements through a mechanism that walks the traces in the code. So in addition to the ticket context, in addition to the requirements which are here, it also looks at where is this going to be implemented and what was done there in the past, which kind of tickets, which kind of requirements, what's there. It pulls in all this, and from all that, it reasons about whether it's faithful to implement this ticket or not. And this takes a couple of minutes, so I've prepared a report for you. This is a report which the skill generates just like this. I haven't changed it in a way. It's what the skill drops. Yeah, it says the ticket name, implement brake fluid temperature monitoring. Okay, good. You picked it up. Great. But then it says content conflicts. Now, what happened? There's another requirement in the requirement system. The author forgot to link to the actual ticket. Yeah, he forgot it. It should be there because it's related to what should be done. The skill found it anyway by walking the trace network out from the function this implementation has to extend. And there's a lot of information in here. Basically, it says the requirement which was found says during emergency braking, no derating signals get applied, including brake fluid temperature. But the ticket says, or a requirement related to the ticket says, above 250 degrees centigrade, reduce the pressure. No exception. Both requirements are active. Both are ASIA related. They contradict each other in exactly the situation that matters most in a panic stop with hot brake fluid. An agent reading only the ticket would have written code that derates the pressure unconditionally and would have shipped a violation of an existing safety requirement that nobody mentioned. Well, the rest of the report is just evidence, what's done, which requirements read, which execution paths in the code were examined, and so on. What matters is how it ends. Stop. Implementation must not proceed. So it's a hard stop. No code is written. The conflict is not the agents to resolve. It goes back to a human in the requirements layer in CodeBeamer. That's the moment I want to take you away here, because we're all used to the fact that AI actually follows the task instead of aborting it.
And that's very impressive. A few weeks ago, I found an article on LinkedIn. Maybe I put the link in the mail tomorrow with the recording, by Ger Cloud. And he claims that the normal traces are not sufficient, but that we will see natural traces, so that in the environment of an artifact, the source code, the requirement will be taken into account. And this is what we have seen just now in practice.
Yeah, that's it. You could follow in depth, so you can go deeper, but you can also, since the requirements are traced all over the code, you can also do a lateral scan, and you will find all code locations, even if they are far away. And that's what the skill does. So to summarize, what you just saw is what AI assistant development needs to look like in a regulated environment. Structural traces give an agent a deterministic network to walk. The skill turns that network into a decision, proceed or stop. In this case, the agent did the right thing. It found the conflict. It refused actually to write the code on top of it, and it handed the decision back to where it belonged, to the person who's in charge of the ticket. So the tooling did the right thing, but the tooling alone is not the point. The process around AI-assisted development has to be built up with guardrails for the AI and for the humans using it. That's why the AI also refuses to implement the proper change here. This is not, especially not in a safety relevant case, up to the AI to solve this issue here. Okay, that's about the presentation. That's what I wanted to show. One thing before we go into questions, I'm looking for pilot partners to take this further. The fit I have in mind is a team working under regulatory pressure. ASPICE, ISO 26262 are similar, where structural traceability is currently maintained by discipline only. Teams already exploring AI-assisted development are especially strong fit, but not a precondition. The setup of the whole system is intentionally lightweight. A Docker container, ALM credentials, Git credentials. That's the integration. You don't need more. It's an hour of setup. Low schema migration in the ALM, no custom plugins, no separate qualification project to start with, nothing. It's as simple as that. And it would be work direct with me, small environment, quick decisions, no sales process in between. If that fits your situation, if you're interested, please reach out. There's everything on this page here, Ariadne-thread.io. The lens demo with 10,000 requirements, the pilot inquiry, the full description of what we do. So back to you, Ron.
Yes, thank you very much for the presentation, Thorsten. And we had two brilliant questions in the chat I would like to read. You can think about more questions while I read this first one. The first one was by Hussein. When the requirements are so close to the implementation, to the source code, will the requirements not polluted by implementation details over time? What would you say, Thorsten?
There's currently there's no way back. I mean, that's what I've shown in the AI assistance. The AI does not write anything back to the requirements. So neither does the developer. So I'd not say that there is any pollution from source code into the requirements.
And the expectations for good requirements still are in place and can be checked by AI in the future. The schema, how a requirement is laid out, and it shall be independent of the implementation, which you can check on the requirements. For smaller teams, of course, the developer might actually write the requirements. For bigger companies, for bigger teams, there's still independent roles. Someone writes the requirements and another one implements the requirements. So I don't see the problem. Of course, we need to take care of this pollution and need to verify that the requirements are not polluted by the implementation. And the second question, also by Hussein, what if we have an architecture detail design layer in between? We actually skipped the architecture and detail design, that's correct. And we had a look at one specific trace here, which from my experience, many teams struggle with, which is from the source code, or actually it's detail design, to the requirements layer. We skipped the architecture and the detail design. And in a full set project or assessment, we would look at the traces between architecture and detail design and implementation as well. So it's one or two traces we had to look at today. The second one is to the test cases, which were briefly mentioned and shown by Thorsten.
And I can add to this, it depends, of course, on the technology you are using. This tool is based on Java. There's a certain testing framework, which also allows for architecture tests. So you could actually trace some of the architecture which are related to software. You could trace them into these test cases which are implemented. So it simply depends whether there is something in the code base which reflects these architectural decisions, like package structure or whatever, however you design your software. Everything of these architecture decisions which you can find in the software, you can trace. If it's not there, you cannot trace it like this. Then you have to trace it in the LM itself.
And I think one aspect I missed, of course, software requirements on the top level are not fully implemented by one part of the software, one unit only. Still, we need the trace from the software requirements to the unit contributing to the requirement, even though this unit might not fully implement the software requirement. This is something which is often misunderstood, that there's a one-to-one relationship between the requirement and the unit, but actually there's a one-to-many requirement trace. Of course, in the presentation today, we kind of simplified this. Okay, yeah. Are there any further questions from the audience before we close? No further questions. Then I would like to close. You will get the recording and all the links in today's, tomorrow's, that's wrong. In an email which will be sent tomorrow to all the participants. And if you have any further questions, you can write Thorsten directly, or you can ask the question now.
Also ein Comment vielleicht, die Tonqualität war sehr schlecht. Ja.
Okay, on which side?
Which side?
Ja, also ich habe mein Mikro ausgeschaltet, meine Kamera ausgeschaltet. Also ich nehme an, das liegt irgendwo anders. Ne? Also es ist schade, das ist ein langer Vortrag und dann hört man es nur mehr rauschen, abgeknackt. Ja. Ich habe ein paar Mal geschrieben, bitte schaltet das Mikro aus, aber ich weiß nicht, ob das alle gemacht haben. Jedenfalls habt ihr immer wieder abgehackte eure Wörter gehört. Das ist schade. Ja.
Okay, okay.
Okay.
Maybe it's better in the recording tomorrow.
Recording.
Okay, then
Also beim letzten Vortrag von dir war das überhaupt auch kein Problem. Ja.
okay, okay. We will check and we will improve in the next webinar, hopefully.
Ja, das ist schade, ja, weil das ist.
As I said, I can refer to the recording which will be sent out tomorrow. Maybe it's better, otherwise we might do the webinar again. Okay, thank you very much, everyone, for joining today. As I said, tomorrow you will get the recording. If you have any further questions, you can reach out to Thorsten or to me anytime. You can reply to the invitation email to me and I will forward you to Thorsten and get you in touch with him. Thank you very much again and see you in the next webinar.
Yeah. Thank you also from my side. Bye-bye.
Bye.
Thank you. Bye.
Bye-bye.